Hello everyone, I'm Paul and today we're solving problem 3025. Find the number of ways to place people 1. This is medium and this is a very visual problem. So next I will show you how to solve this visually and then we will go with the code. We are given a 2D array points which represents coordinates for some points in a 2D plane. So if we're given these points, this is the visual representation of the points. And we need to count the number of pairs, for example, this and this, where point A is in the upper left side and there are no points in between these two. So given that there are no points in between this and this is a valid pair. And for example, this is also a valid pair. But this is not a valid pair because we have a point here in between these two. So given that in total we have 2 valid pairs, we return 2 in this case. Now the question is, how can we solve this? And the first thing we can do here is to check the constraints. We know that we can have 50 points or less. So this is a relatively small number. We can think in terms of n squared or even in terms of n cubed. And what this means is we can check for every possible pair of points. We can check the pair for these and these points. We can check these and these points. And we can check these and these points in this case. So let's say we are checking these and these points. Now, every time we will have another loop to check if every other point, in this case only this one, is in between these two or not. So we have one for loop to check for every pair of points, this and this, this and this, and this and this. And we have another nested for loop right here to check for every other point that's not in the current pair. So if we are with this pair, we are checking if this point is in between these two or not. In this case, it's not, meaning this is a valid pair. So we can add 1 to the result. When we are checking this pair, the only point that's not included in this pair is this one. So we can check if this is in between these two. And in this case, it's not, so we can add this to the result also. This is how we can return 2. For example, when we are checking this pair, the only point that's not included in this pair is this one. And this is in between these two, so we can't include this pair in the result. And how do we know if this is in between these two? Well, we have the coordinates, so we know that this point has the coordinate 2, 6. It's right here. So we know that if we have some point in this range regarding the y-axis, in this range regarding the x-axis, this means this is in between this and this. So in this case, this is not a valid pair. When we are with this pair, for example, we are looking at these bounds. This is regarding y-axis and this is regarding x-axis. So we are checking if this is in this range and in this range. In this case, it's not. So this is a valid pair. So now with this, I think you get the idea. We are iterating every triplet of points. We are iterating every pair, and from every pair, we are iterating every other point. So with this in mind, now let's go with the code. First, we say n is the length of points. The result is initially 0 and we want to try every pair of points. So for I in range n, for j in range n. And if I is equal to j, we can just continue because we need pairs of different points. Here we can say ax, ay is points I, and here we can say bx, by is points j. And now we can check the first condition. If the upper left corner of the current pair or the current square is not point A, we have to continue. And what this means is if not ax is smaller or equal to bx and ay greater or equal to vy, we just continue. And now we can check the second condition, meaning we need an empty square. If we find any point that's not in the current pair and it's in our current square, we also have to continue. And how can we check this? Well, we need another for loop. We'll have a boolean, we'll call this skip. This is initially false. And now we are iterating every other point that's not part of the current pair. So we say for k in range n, if k is equal to I or k is equal to j, we just continue. And here we can say cx, cy is points k. And now we are checking if this new point is in between A and B. So if cx is greater or equal to ax and cx is smaller or equal to bx, and regarding the y-axis, we can say cy is smaller or equal to ay and cy is greater or equal to vy. So if we have some point in between, skip is true, and we can now break this loop. And here we can say if skip is false, we can add 1 to the result. And finally, after all of this, we can just return result. So this is it for the code. Now let's submit this and see if it works. As you can see, this works and it's very efficient. Time complexity here will be big O of n cube and space complexity big O of 1. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.